Okay, this is the last module of the whole course. I just want to remind you in the last module, so in module 1 or module 7, lecture 1, I actually talked about the final assignment. So just as a reminder to show you all, I definitely watched that video, but the final assignment you can find here, and it'll be due before the end of, you have a little bit more time for this one. But here, I have this. Also, complete your course evaluation, please, if you have a chance. This is the final project. And if you look at it, open it up, here's kind of a description of what I want you to do. And if you don't recall, go back to the last lecture. So in module 7, lecture 1, I have discussion of that. Okay. So this is the very last lecture of the class. I hope you've enjoyed the class. Please leave me a review. It will help. I don't know if I'll be teaching this next time around, but it will help whoever's teaching, what worked, what didn't work. It was my first time, so it'll be helpful for me or for whoever teaches this class next time. So here the module is module 7, lecture 2, how to work with a statistician and when to ask for help. Okay, so I did not teach you nearly enough to be competent in statistics. The goal of this class, I'll teach you a little bit of functions. If you want to learn more, if you end up going to graduate school or anything like that, you'll probably be using statistics. You'll probably be getting more familiar with this. All I've given you is the basic tools to be able to do a couple of analyses in R if you need to. And also, hopefully, you have a little bit better understanding of what you might be reading or seeing. It's not expert to make you an expert. And I put this here, right? You wouldn't trust I don't have a statistician to diagnose a disease based on a 1-hour lecture. So like you wouldn't, trust a doctor, somebody to operate on you if they've watch a couple of YouTube videos. So PhD statisticians, they have 6 years plus experience in data analysis. They have a lot of experience doing this, and talking with them early can really help you. So before your study, if you're going to submit an IRB or grant, you'll need a statistical plan. Oftentimes, when you plan a study, you might not collect the variables you actually need, and a statistician can help you do that. They can also give you a power analysis. So what's your power of your study? What sample size do you need to get XX power? And again, your probability power is the probability to find a statistically significant difference when there is one. Data analysis. If you give your statisticians data and declare what they need, they can help you and help you write a paper, submit an abstract, whatever you're doing. You could start by emailing them your data set, 2 or 3 paragraphs of summary. Sometimes they'll know what to do, but mostly they'll want to chat with you over the phone or Zoom or something like that. And statisticians, they mess around in a lot of different areas. Like I work with a bunch of different groups, but like I'm not an expert in any of those groups. So, if you're working with a statistician to help you in your area of expertise, make sure you level with them. Once they're clear on what they'll done, they'll try it out. Most of the time, they'll notice something weird about their data and they'll ask you questions. Then they'll give you really crude results and explanation of what the results look like. You'll probably have some more requests and they'll go back and make those changes in the end. So that's usually done at the end after some back and forth and everybody's kind of agreed on the story that the data analysis is going to tell. The statistician will crank out the final analysis. Again, dues, go see them early. Ask them, tell them, have a hypothesis. So you don't really want to fish, hey, make sense of the data. Have some idea of what the data might say before, what you want to look at. Remind them of your projects. They work with lots of different people. Don't expect results right away, and don't change the data after the paper is fully read. Lots of times data can have missing values or misspellings. You can definitely help this ahead of time. So you might see, for example, a cancer patient's cancer is TV. Do you mean T1? Sometimes it can be like 2 specific insurances, like granular. Sometimes racial groups can be like a little too granular too, where you only have like one person that's Pacific Islander or something like that. That can happen. And other things to think about, right? There's other statistical settings beyond this course. There's many areas of statistics and the available methods grow every day. Tons of research, and we'll list some interesting examples on the next couple slides. So time series is something that we didn't really get in this class, but it's something to consider. Think about stock market price. Like you want to know what's the price of Apple at any minute of their trading cycle for a given year. Well, then you'll have Apple. You could have also Google together. So you could have a whole time trend for Apple, a whole time trend for Google. You can also have time varying covariance, so volatility. What's the opening price of the day? So maybe you want to predict what's the price at the end of the day based on the initial day. The methods that we have in class won't work for this because those methods assume that your data points are all independent. But if I have a measurement of a price of Apple today versus Apple next week, they depend on each other, right? Because they're the same stock. Everybody knows it's Apple, right? Apple's a valuable commodity. Graphical models you'll also see. So consider Facebook. How do people interact with each other? So you can see here 4 people from this graph. You can see that person 1 talks to persons 2, 3, 2, 5, and 3. Person 2 talks to person 1 and person 4. Person 4 just talks to person 2. Person 3 talks to person 1 and person 5. Person 5 talks to person 1 and person 3. So graphical models, you can do this for modeling like brain connectivity, who is talking to who, what factors influence each other. These are things that will start to pop up more, and you will probably see a little bit more often. Variable selection. So consider linear regression. Variable selection is another kind of field that we didn't talk about here. So maybe I choose 5 variables to consider in predicting BMI, for example. Which variables are the most important? So I can use variable selection, I can use stepwise, I can use backwards, I can use machine learning, I can use Bayesian methods. That's a big area of research. So if you have a lot of variables that you're interested in what impacts outcome, this might be sort of an area that you might want to look into. Spatial analysis. So spatially, how do things relate to each other? Consider Houston. Houston has air monitors around the city. Goal is to give public alerts if the air is too toxic. It might depend on weather, proximity, time of the year, etc. You can imagine modeling spatial patterns, weather patterns as a function of data, and many more. So again, there's over 30 statistical journals. They're publishing new methods every day. If you think your data doesn't fit into one of the things we talked about in class, it probably doesn't. And then consult a statistician. I hope you've enjoyed the class. Please give me a review, leave honest feedback. And yeah, you'll have this last assignment. Reach out to me if you have any questions or hey, does this work or does this not work? And I'll be happy to help you. All right. Hope you all have a good rest of the semester and have a good rest of your year. Bye.